This is Professor Stephen Litch in the Principles of Economics talking about firms' behavior in competitive markets. There are two or three important characteristics of competitive markets. First, many buyers and many sellers. And second, they all sell an identical product. I have several good examples of competitive markets. One is the market for gasoline. You can imagine driving down the street and seeing several gas stations, one after another. So that's the idea of many sellers with identical products. A gallon of gas from one station is essentially equivalent to a gallon of gas from another. Another example might be milk or farmers who raise crops like soybeans, wheat, or corn. You can drive down the road outside of Elon, Burlington. You can drive down a country road and see one field growing corn after another, after another, after another. All of those farmers are raising essentially identical products. Okay, what this means, or what these two characteristics imply, when there are many sellers of an identical product, all will behave like price takers. And that is an important concept for competitive markets. When I say price takers, I mean that no one seller has the ability to set the price separate from what is just going in the market. If all the other farmers are receiving $100 a ton for corn, I, as a single farmer, would not be able to demand that I be paid $110 for corn. If the corn buyers can purchase as much as they want at $100, why would they come to me if I'm charging a higher price? Similarly, if I want to sell my corn and I know that I can sell it for $100 a ton, I would have no reason to ask any lower price. Why ask $99 a ton, a lower price, if I can sell everything I want at $100 a ton? Okay, so when there are many sellers in a market and they all are selling an identical product, they will behave like price takers. Nobody can set their own price. A final important characteristic of a competitive market in the long run is firms are free to enter and exit the market. That's a little bit different from some non-competitive markets, like a monopoly that might be protected by a patent. If some company invents a new product, their new invention is covered by a patent that prevents anyone else from being able to produce that same good. That is not a competitive market, and that is specifically not free entry into a market. Okay, I want to remind you all of how firms behave. First and foremost, firms exist to maximize profits. In our economic models, we simplify firms to doing just that. They want to make as much money as possible after paying the costs of production. They want to make as much money as possible. Remember, profits are defined as the difference between the revenue the firm takes in and the costs the firm pays. Okay. A second thing about firms' behavior is that a rational firm, a rational business owner, rational people all think at the margin. And essentially, any decision a firm makes can almost all the decisions can be reduced to simply, is the marginal revenue greater than the marginal cost? If so, do it. So when the firm is thinking about how many workers to employ, essentially the question is, for each worker, does this worker bring in more revenue than the cost of employing this worker? If so, the firm should employ the worker. when the firm is thinking how much to produce. The question is always, if I were to produce this one widget or this additional widget, does it bring in more revenue than the cost of producing it? Again, is marginal revenue greater than marginal cost? Remember, marginal means the extra whatever from this unit. So the marginal revenue is the extra revenue the firm gets from producing this unit. Marginal cost is the additional cost from producing this unit. Okay, so that's the second important thing about firms' behavior. Now, the first topic that I'm going to cover is how a competitive firm decides how much to produce. I'm going to go through several examples. I'm going to start with just a cost function for a firm. This firm, I suppose, has sat down and figured out that if they were to produce one widget, they could do it at a cost of $22. They could produce two widgets at a cost of $26. They could produce three widgets at a cost of $32, and so forth. They've priced out what it would cost to produce anywhere between 1 and 8 widgets. Now, I have to apologize for something that I left out of this table, which I'll scribble right here, right now. I'd intended to add that the firm could produce a quantity of 0 at a cost of $20. Okay, in other words, this represents the fixed cost for the firm. If the firm just opens up, produces nothing, it still has a fixed cost of $20. Okay, so again, I apologize for omitting that from the table. I'll refer back to this on later slides. Again, let me return. The decision that the firm is trying to make is how much to produce and sell. Remember, the objective of the firm is to maximize profit. Okay, the optimal quantity to produce will depend on the price. And remember, the firm is going to accept the price that the market is paying. The firm doesn't get to set its own price. Suppose the firm can sell the widgets it produces at a price of $14 a piece. Let me work out the profit maximizing number of widgets to produce and sell for this firm. In order to figure out the profit maximizing amount, I'm going to calculate the revenue from producing 1, 2, 3, 4, 5, and so forth widgets, and then the profit that the firm gets. Okay, the revenue, remember, revenue is, total revenue is price times quantity. So when the firm sells one widget, quantity of 1, at a price of $14, the total revenue is $14. Selling 2 widgets at a price of $14, the revenue is $28. So I've continued that pattern down this column. By the way, you should be accustomed to filling in these tables, and given a cost function for a firm, you should be able to find the profit maximizing output at a particular price. Okay, so again, quantity was given. I've calculated total revenue. The next step is to calculate the profit the firm would get. If the firm were to produce one widget, selling the widget, it would get $14 of revenue. The total cost of the firm would be $22, and the profit would be negative $8. In other words, the firm would have an $8 loss. If the firm were to produce 2 widgets, selling each at $14, the firm would have $28 of revenue, the costs of the firm would be $26, and the profit left over, $2. Selling 3 widgets, $42 of revenue minus $32 of cost leaves $10 of revenue. And that's the pattern for calculating this profit column, just total revenue minus total cost. And we can look down the profit column to see what output would maximize profits. The most profit the firm can get is right here, $22 of profit. That happens when the firm produces either 6 or 7 widgets. Just as a note, whenever there is a tie, like two different quantities that will both produce the same amount of profit, we always go with the larger one. That's just the convention in solving these economic problems. Go with the larger of the two values. So we would say that the profit maximizing production level is producing 7 widgets, which results in $22 of profit. Okay, but what if the price is different? What if the price of a widget were $6? We can find the profit maximizing level of output, though we have to work out this table again. A little bit later, I will show you all a shortcut that always works, but I want to do this the hard way first, which is literally calculating profit when the firm produces however many widgets. First, I calculate the total revenue from selling 1, 2, 3, 4, 5, and so forth widgets. If the firm sells, for example, 3 widgets at a price of $6 a piece, total revenue is $18. Selling 7 widgets at a price of $6 a piece, total revenue is $42. This total revenue column is price times quantity. Then profit is total revenue minus total cost equals profit. So when this firm produces 5 widgets, for example, it sells each of them at $6 a piece, so it has $30 of revenue. The cost of production is $50. The profit is then revenue minus cost. The firm has a profit of negative $20. In other words, a $20 loss. All of this profit column is calculated as total revenue minus total cost. To identify the amount of output that would maximize profits, we can scan down this profit column to see what achieves the highest profits. In this case, negative 14 is the highest profits the firm can get. Firm gets that when producing 3 widgets. So when the price of a widget is $6, producing 3 widgets maximizes profits. And since all the profits here are negative, maybe it would be more correct to say producing 3 widgets minimizes the loss. One question that might come to mind is, why is this firm operating if it's earning a loss, if it's earning negative profits? Let me go back to the costs if the firm produces nothing. Remember, the firm had a $20 fixed cost, so if this firm were to produce nothing, it would have $0 of revenue, a total cost of $20, and profit of negative $20. Again, that was the firm's fixed cost. It had some commitments it needed to pay no matter how much it produced, like the rent for the shop that it owns. In this case, shutting down would mean that the firm has to pay the entire fixed cost of $20, whereas remaining open and producing $3, remaining open and producing 3 widgets results in just a $14 loss. So if it's a choice between shutting down and paying a $20 loss or staying open and receiving a $14 loss, the firm does maximize profits or minimize its loss by staying open. Firms might be forced to take a loss in the short run when they have some fixed costs that they cannot get out of. To be honest, I think that's happening for many restaurants and other businesses during the COVID pandemic right now. They do operate at a loss, but at least they're getting enough revenue to pay some of their fixed costs, to cover all their variable costs and some of their fixed costs. Okay, I just wanted to mention that or address that while I had an example of a firm that would still remain open and produce 3 widgets, even if it is operating at a loss. Let me work out a third example for maximizing profits, choosing quantity to maximize profits when the price of the widgets is $10, when the firm can sell each widget for $10. As before, the first step is filling in this column for total revenue. When the firm sells, for example, 7 widgets, it gets $70 of revenue. Total revenue is price times quantity. Next step, I calculate profit. Producing 1 widget, the firm has $10 of revenue, $22 of costs, so the profit is negative $12, or a $12 loss. Producing 2 widgets, the firm has a $6 loss. Producing 3 widgets, a $2 loss. And here we have producing 4 widgets or 5 widgets generates no profit and no loss. After that, the losses start increasing. I'll just make a note here. When we're working out these problems, there's always going to be increasing profits up to a point, and then the profits start to decrease again. So if you're working down this column and you notice profits keep increasing, and then profits begin to go down, you actually don't need to work any further than the quantity of 6. If quantity of 6, the profits are going down, they will continue to go down even more and more. Okay, so working this out, we come to the conclusion that the firm maximizes profit by producing 5 widgets. Now, I'm going to take those values and translate them into the firm's supply curve. So here's a basic graph, price, quantity, and I want to show the quantity that the firm is willing to produce at each price. That's the meaning of the supply curve. We solved that when the price is $6, the firm was willing to produce 3 widgets. When the price was $10, the firm was willing to produce 5 widgets. When the price was $14, the firm was willing to produce 7 widgets. Those points together generate the supply curve. Remember, the supply curve tells us the number of widgets that the firm would be willing to produce at each cost. And we could go through and solve for each price what number or what production would maximize profit, what quantity would maximize profit. I've done it for these 3 points to produce this supply curve. Now, I want to talk through a different approach to solving the profit maximization problem. Instead of working out profits for each level of production, there's a shortcut to determining how much the firm should produce. The basic idea is thinking at the margin. I've said this before. A rational approach to maximizing profits is to think about each widget and how much revenue that widget would bring in versus the additional cost of producing that. The economic word marginal means the additional whatever. Okay, so the additional revenue from selling this widget, that's the marginal revenue. The additional cost of producing this widget, that's the marginal cost. The basic logic for a business is the business should do anything where the marginal revenue is greater than the marginal cost. In this case, the competitive firm is thinking about how much to produce, and the revenue it gets from producing another widget is the price. If the price were $7, producing another widget, selling that widget, would bring in $7 of revenue. So let's keep that in mind. That's the marginal revenue for each widget. Then we need to work out the marginal cost. The marginal cost is the change in cost for producing this widget. Let's start with the marginal cost of the second widget. When the firm increases production from one widget to two widgets, the firm's total costs increase from 22 to 26. In other words, the firm's costs increase by $4. That's the additional cost of producing a second widget. That's the marginal cost of producing the second widget. Increasing production from 2 to 3, that extra widget increases costs from 26 to 32. It increases costs by $6. The marginal cost of the third widget is $6. The fourth widget increases costs by $8. Fifth widget increases costs by $10, and so forth. Suppose the firm takes this marginal approach to determining the profit maximizing quantity to produce. In other words, in this case, the firm would decide that if the price of producing a widget is greater than the marginal cost, produce it. Then stop at the quantity where price equals marginal cost. Following this rule, what we're going to see is the firm comes to the same conclusions about what quantity will maximize profits. On top of that, this approach is faster to work out because we don't need to recalculate profit for different prices. Once we have the marginal costs, we can find the profit maximizing quantity at each price. For example, when the price is $6, the firm can evaluate each quantity and ask whether the price is greater than the marginal cost. The first widget that the firm produces, it can sell at a price of $6. So that first widget brings in $6 of revenue, and producing the widget adds $2 to the firm's cost. For that first widget, brings in $6 of revenue, it costs $2, so it's profitable to produce it. Second widget, it adds $4 to the firm's costs, but it brings in $6 of revenue. Again, it's profitable to do that, so the firm does produce the second widget. The third widget, it brings in $6 of revenue. It costs an extra $6 to produce it, so the firm might as well produce it. The firm would be willing to produce it, which is part of our definition of supply or quantity supplied. Whenever there is a tie, like price equals marginal cost, let's just go ahead and say the firm does it. And the rule here, stop where the price is equal to the marginal cost. Okay, in this case, that means stop when the firm produces 3 widgets. In conclusion, when the price is $6, the firm would decide to produce 3 widgets. If the price were $10, the firm can use the same table to identify the profit maximizing quantity to produce. First widget can bring in $10 of revenue, and it has $2 of cost. So, profitable. Second widget brings in an extra $10 of revenue and costs an extra $4 to produce. Again, it's profitable. The firm keeps going down. the fifth widget brings in $10 of revenue, adds $10 to the cost, so the firm's willing to do it, but not produce the sixth widget. The sixth widget would bring in $10 of revenue, but it would cost $12 to produce, so it's not profitable. That's a loss. The same for the seventh widget. Brings in $10 of revenue, costs $14 to produce, not profitable. So the firm will produce widgets up to the point where price equals marginal cost, then it stops. And that means that when the price is $10, the profit maximizing quantity would be $5. The last example is when the firm can sell each of its widgets at a price of $14. Again, the firm can run down this column for marginal cost and know that it should keep producing widgets as long as the price is greater than the marginal cost, and then stop when it gets to the point where price equals marginal cost. So stop producing when it gets to the seventh widget. In other words, when the price is $14, producing 7 widgets will maximize the firm's profits. So in all 3 of these examples, the firm comes to the same conclusion by thinking in terms of marginal cost versus marginal revenue that it would have if it calculated out the entire profits at each price for each quantity. This marginal approach is logical, simpler, and faster. In this next step, I want to plot out the firm's marginal cost curve. We calculated these marginal costs earlier. The marginal cost of the first widget was $2. Marginal cost of the second widget was $4. Of the third widget was $6, and so forth. I've put those points down here. If we do connect the dots with these points, we get the firm's marginal cost curve. I want to compare this marginal cost curve to the firm's supply curve. Keep a couple of things in mind. The marginal cost of the third widget is $6. The marginal cost of the fifth widget is $10. Marginal cost of the seventh widget is $12. Now let me flip to the this one, the supply curve. Supply curve goes through exactly the same points. Supply curve, we determined that when the price was 6, the number of widgets the firm would want to produce was 3. When the price was 10, the number of widgets the firm would want to produce was 5. At the price of 14, the firm would want to produce 7. All of these points on the supply curve are the same as the marginal cost curve. So here is an important thing for a competitive firm. The supply curve of a competitive firm is the same as the firm's marginal cost curve. Now let me summarize how a firm decides the output to produce that will maximize profits. For all firms, the profit maximizing output is where marginal cost equals marginal revenue. For a competitive firm, the revenue it gets from selling each additional unit is the price. So marginal revenue equals price. So this rule becomes the profit maximizing quantity is where price equals marginal cost. This is hugely important. This is something you should remember. This is something you should expect to see on tests and exams. This is also something that if you continue in economics, you definitely need to know. Next, I want to talk about a firm's decision to possibly shut down in the short run. My hypothetical firm that I've been using for examples in this lecture earned a loss no matter how much it produced when the price was $6. Of course, that's not a good thing, and the business owners would probably prefer not to be making a loss. The firm has 2 choices in the short run. It can shut down which means to stop production, though it still has its fixed costs that it must pay. The alternative is to stay open, and then it gets the revenue from what it sells, however much it decides to produce, it gets that revenue, but then it pays the fixed cost, of course, as well as the variable cost of production. So if you think about these two options, either way, the firm has to pay the fixed cost. So that doesn't matter, right? The amount of the fixed cost is not going to influence the firm's decision whether to shut down. It boils down to, if the firm stays open, it receives revenue of P times Q, and it pays variable cost. Then the firm should shut down if the variable cost is more than the revenue it gets, okay? Or shut down if price times quantity is less than its variable costs. We can rewrite that a couple of ways. Divide both sides by Q. The firm should shut down if price is less than variable cost divided by Q. Variable cost divided by Q has a name. It's called average total cost. So the rule for the firm is it should shut down if the price it receives for its product is less than its average variable cost. The firm should shut down if the revenue it receives is not enough to cover its variable costs. In that case, it's just digging itself deeper into a hole. It had to pay the fixed cost no matter what. On top of that, the revenue it receives is not enough to cover even the variable costs, so that's even more of a loss. On the other hand, if price is greater than average variable cost, the firm wants to stay open. Even if it is making a loss, it is earning more in revenue than its variable costs. So it can pay for all its variable costs and then pay some of its fixed costs. So remember, firms may stay open in the short run even when they are receiving a loss because they have these fixed costs. And as long as they are committed to paying their fixed cost, it might be better to stay open, produce something that gives some money that helps pay down the fixed cost. That might be better than just shutting down entirely and having to pay all the fixed cost on its own. The firm won't always have these same fixed costs. The fixed costs can be changed in the long run. So for example, one fixed cost might be the cost of renting a shop. When the lease is over, that fixed cost goes away. Or the firm might have taken out a loan and have some debts that it needs to pay off. Eventually those debts will be paid off and the fixed cost is gone. Economists talk about the short run versus the long run. The long run is defined as however long it takes the firm to get out of all of its fixed costs. In the long run, the firm has the option to completely exit the market, and then it pays no fixed costs whatsoever. Or it could stay in the market. Also in the long run, firms can enter the market. If someone wants to open up a new widget factory, the person can. Of course, that's not a decision that a person can make from one day to the next. It takes time to enter the market. Again, the amount of time that it takes to make that adjustment is called the long run. So when we talk about the long run, that is essentially just however long it takes to make all the necessary adjustments is the long run. The short run, some things are fixed. In the long run, firms have three possible choices. They can exit the market, stay in the market, or new firms can enter. Let me talk about the decision to exit the market. A firm will exit the market if it's making an economic loss. That happens when the total revenue of the firm is less than the total cost. Let me work out some math to show what that means. Total revenue less than total cost. means that price times quantity is less than total cost. Then dividing both sides by quantity, price less than total cost divided by quantity, which means price is less than average total cost. If the price in the market is less than the firm's average total cost, the firm will want to exit the market. As firms start leaving the market, the price is going to rise in the market. In fact, these firms exiting the market will start to move toward a long-run price that is essentially sustainable for the businesses. They couldn't make a profit when the price in the market was less than their average total cost. They might have stayed open in the short run because it helped them pay down their fixed costs, but as soon as they can, those firms would want to exit the market if the price they receive is less than their average total cost. As the firms start to exit the market, that's going to bring the price up, and hopefully at some point it'll be where the price is enough to cover their average total cost. But next I want to talk about firms possibly entering the market in the long run. If this market is unusually profitable, if people can make more money selling widgets in a widget shop than they can in other business opportunities, people are going to want to start opening up new widget shops. When the total revenue a firm receives is greater than the total cost, the firm is making a positive profit. And let me be specific. We mean an economic profit. That means that the firm has already paid its owners a normal return on their investment, and the firm is still making more profit on top of that for the owners. It's making positive economic profit. I could work out the math to show that positive economic profit happens when price is greater than average total cost. So when firms can sell their widgets at a price greater than their average total cost, the firms will be making positive economic profits, and new businesses will want to enter the market. That's going to start putting pressure on the price to come down. As there's more competition in the market, the price of the widgets will fall. I've talked about the conditions that would cause firms to exit the market or to enter the market. Now let me do the condition that would cause firms just to stay in the market. Nobody wants to leave and no one wants to enter. This is what an economist calls an equilibrium, where there's no pressure for the market to change in one way or another. Firms will want to just stay in the market if the total revenue they receive is equal to their total cost. Remember, we're counting a normal return on investment as one of the costs of doing business. A normal return on investment, that means giving the business owners a normal amount of profit. Economists consider normal profit to be, in fact, a cost. This is one of those confusing things. It's a difference in perspective between economists and normal people, but that normal rate of return or that normal return on the investment is considered a cost. So when firms have total revenue equal to their total cost, that includes paying the normal profit to the business owners, then there's no desire for firms to exit the market. The investors are happy. They're making the same return from this business as they could elsewhere. They're content, and there's no pressure to enter. It's not an unusually good business opportunity. So if I were to work out the math here, total revenue equals total cost implies that price equals average total cost. In other words, when the price is equal to the average total cost of the firms, the market is stable. There's no pressure for firms to enter or leave, and there's no pressure for the price to come up or go down. That's what we call an equilibrium. So let me summarize what will happen in the market in the long run. If the price in the market is less than the average total cost currently, then in the long run, firms will want to exit the market. This is going to cause the price to go up and move in the direction of price equals average total cost. On the other hand, if the price is currently above average total cost, firms will want to enter the market in the long run. As firms enter the market, they will drive the price down and drive price in the direction of being closer to average total cost. Finally, the equilibrium in the long run occurs when price equals average total cost. The market settles down at that point. Here's another big important result. In a competitive market, the long-run equilibrium price will be the minimum average total cost at which firms can produce. Okay? There's exactly one price that can be an equilibrium in the long run, and it is the lowest possible average total cost for firms. At that point, the firms are making zero economic profit. Again, I'm going to remind you all that zero economic profit means they're making a normal return, but nothing above that. By the way, this result about the long-run price is the minimum average total cost is a really neat thing about competitive markets. It means competitive markets are really good for consumers. In the long run, firms are producing their goods at the lowest cost possible. Again, that's great for consumers. Competition also drives the profits of the businesses to zero. The business owners are just basically breaking even on having their money in this business or sticking it in a bank account or something else. They are not making unusually high profits in a competitive market. Let me flip back to the cost function of my hypothetical firm that I've used in this lecture. Remember, it could produce one widget at a cost of $22, two widgets at a cost of $26. Let me add the average total cost of production. When it produced two widgets, for example, at a total cost of $26, the average total cost was 26 divided by 2 equals $13. Producing three widgets at a total cost of $32 means that the average total cost was 10 2/3. Producing four widgets at a cost of $40, average total cost was $10. Producing five widgets at a cost of $50, average total cost was $10. Producing six widgets for a total cost of $62, average total cost was $10 1/3. Then producing seven widgets, total cost $76, average total cost is $10.86. Okay, we've identified the minimum average total cost in this market, or the minimum average total cost for this firm is $10. Since the lowest average total cost the firm can achieve is $10, that will be the long-run equilibrium price in this market. The long-run equilibrium price must be $10. Earlier, we worked out what a firm would do if it sold widgets at $10 a piece. When the price is $10, the firm maximizes profits by producing 5 widgets. It receives 0 profits. So this is also consistent with what I just said about the long-run equilibrium. The long-run equilibrium price is the minimum average total cost. So in this case, the minimum average total cost was $0. That must be the long-run price in this market. At that price, the firm would produce 5 widgets. And as I said, firms will make zero profit in the long run. Okay, so this has been a long lecture and parts of it have been dry. I want to summarize some important things about competitive markets. First, remember the definition of a competitive market. There are many sellers of an identical product. Firms want to maximize profits. There are two things they do. First, they take the price as given. They don't try to set a price. They just accept the market price. Second, they choose the output where marginal cost equals price. If they produce Q star where the marginal cost equals the price, they will maximize their profit. Next point, the supply curve of a perfectly competitive firm is the same as the firm's marginal cost curve. Next, firms have the option to shut down in the short run. Shut down means that they pay their fixed cost, but they produce nothing. And firms will shut down if price less than average variable cost. In the long run, a firm can exit the market. That means paying no costs whatsoever. A firm will exit the market if price is less than average total cost. The flip side of that is firms will enter the market if price is greater than average total cost. Next, we can predict that the long-run equilibrium price in the market will be the firm's minimum average total cost. That's the only thing that can be an equilibrium in the long run. And finally, in the long run, all firms in a competitive market will be making zero economic profit. That was a long lecture.